Thank you for asking. Um, exactly. So, welcome to another session, another by time session. We do this every Wednesday where we take a particular topic. It could be that we are solving a particular CTF or CTF challenge, or maybe we are basically building something, right? We do this every Wednesday. We just share knowledge over here and then we present something and we all learn something, right? So we are starting a new session where we want to build custom tools for ethical hacking, right? Because almost every time that we want to perform ethical hacking, there are certain tools that we use to perform those tasks, right? Now, have you ever wondered what actually goes into creating those tools? How do those actually work in the background? You understand? Now, it's necessary to understand how these tools work because maybe you meet a particular problem that you're having with the tool, right? You want to debug and see whether it fits the tool to match your particular purpose, right? If you don't have any prior programming knowledge, you might not be able to do that. So before you can hack something, right, you must understand how the thing is working, right? So if you're able to understand how applications, right, you can hack them easily, right? So in this particular session, we want to push away being a script kiddie, you understand? Just picking up go basta and running it, picking up nmap and running it. We actually want to get our hands dirty. We want to build our own offensive tools, right? The first tool we are going to be starting with is a port scanner. There are other amazing things we could even buy, right? Maybe in the future we could even look at maybe building a reverse shell, like something very interesting. You guys could also come up with suggestions, and then we would try to build it on this stream, right? So as I'm going through this thing, if you have any questions, right, if you have anything that you don't understand, just let me know. I'll be glad to just brush over it and then help you understand it better. Okay. So today's session, as I already said, we building a port. We'll be building a port scanner, right? And before we even start building a sports scanner, right? You see, when you want to write code, you don't just wake up and then start writing code, right? You need to have a plan, right? You need to understand what you're doing before you even start in the first place, right? So I'm just going to be talking about some things that relates to port scanning, right? And the kind of knowledge we need to be able to build a port scanner, right? I think someone is not muted. Can you mute? All right. So I hope you can all hear me and you can see my screen, right? All right, so let's proceed. Yeah, hello. Can you all hear me and see my screen?
Yeah, all loud and clear. We can see your screen.
Okay, that's wonderful. All right, so first we need to know what a port scanner is in the first place. What exactly is a port scanner? For someone that is new to maybe cybersecurity, the technical aspect, and doing ethical hacking, you might not even know what a port scanner is, right? So we be able to define what a port scanner is before we even start building the tool, right? So a scanner is basically an application, right, that is supposed to probe a host or server to identify open ports. Right? So basically, it's an application that we just run against a particular server to see which ports are open on the server. Right? There's another definition over here. It says a port can check network ports for one of three possible statuses: open, closed, or filtered. Right? So it's checking the port to see if they are either one of these three statuses. Right? The port can either be open, closed, or filtered. Right? So basically when we want to do podcast, these are the statuses that we look at to see if the port is available for us to interact with. You may be wondering what a port is, right? If you've also not heard about ports before, maybe you've also heard it several times, don't know exactly what it is. We're going to speak about it in the next slide, right? So what exactly is a port? I know you've heard it countless times, and basically when you are doing ethical hacking, you get to interact with ports a lot, right? But actually understand what a port is, right? So a port is basically it's the way a computer application, right, is able to expose service to the network and to other applications, right? So a port is basically a way for other or different applications to be able to communicate. It could be either on a network or it could be on the same computer, two applications on the same computer communicating, or two applications on two different networks communicate, right? So we have when it comes to the real world, right, you can talk of a port like a door, right? So there are different doors and different things that you can get access to when you go to some particular type of door, right? Let's say you have a house, right? And maybe you have five doors. And then when you go through maybe the bathroom door, it means you are getting access to the bathroom. When you go through the living room door, you are getting access to the living room. That's what basically port is, right? It's supposed to help you to access a particular service that is on the computer, right? So there are different ports and they are normally denoted by port numbers, right? So to be able to identify ports, we use port numbers to identify them. There are some default port numbers that we normally see, like port 80 and port 22, right? So normally port 80 is for web traffic and port 22 is for SSH. And maybe you can about SSH later on, but let me just give you a brief description. SSH is a way by which we are able to connect to uh, a remote PC, right, and be able to access it, right, and control it remotely. Okay, so you can see from the definition here, port is basically a communication endpoint in a computer's network that allows data to be sent and received. That's the basic definition, right? We want to be able to communicate to some particular application on the computer, right? And we need a means by which we can pass information to that particular application. So we use the port. I hope it's clear. If you have any questions, you can ask right now. I'm ready to answer any questions you have. All right. So I'm guessing there are no questions to this point, right? Okay. So as I said, ports can be identified by their port numbers. So we have 80 for web traffic, 22 for SSH, and I think there's 445 for SMB. Like there are a whole lot of them. I think the total number of ports that you can have on a particular PC, right? On one PC is six 655 ports, right? 6555 ports. Yeah. So those are the total number of ports that you can have on a particular machine. Right? Normally, when you want to hack something, right? When you want to hack a particular computer, right? You need to be able to interact with that particular computer, right? Or you need to be able to interact with the applications that are running on that computer. And we do the port, right? So if you want to hack some particular computer through uh, port 80, that is maybe the website that that particular computer is exposing, right? You can use the port 80 to attack that particular computer. You know? All right. So you can see that port numbers or ports are very useful to we ethical hackers because that is how we are able to interact with the applications that we want to hack or we want to test, right? So let's look at the different types of port scans. Now, if you've used Nmap before or any port scanning tool before, there are two modes of port scanning, right? You can either do a TCP scan or a UDP scan. Now, these two are really different. They are basically communication protocols, right? But they work differently. With TCP, right? With TCP, there is what TCP tries to achieve is that there should be an established connection, right? Both devices should be aware of each other's presence, and then they should know that they are both active to be able to exchange data, right? So let's say I want to send data to Kowalski. Let's just say I'm a PC, right? I want to send data to Kowalski. I'll first, if I'm using the TCP protocol, right, before I send that data, I want to see if Kowalski is alive before I send him that data, right? Because I don't want to send data and then maybe Kowalski doesn't receive it. So before I even send the data, I want to establish a connection and make sure that Kowalski is alive before I even send that data to him, right? So that's what TCP basically does. So before TCP, or before data is sent using TCP, right? Or before data is sent, right? TCP tries to establish a connection between the two computers, right? And when the connection is established, then data can be exchanged, right? With UDP doesn't really care about the other end, whether the other end is alive and ready to receive what data. What will happen with UDP is that the sender just sends the information to some particular target IP address. Doesn't verify to see if the information has arrived in order, right? Or it doesn't even verify to see if the other device is actually alive and accepting those packets that are being sent on the network. Right. So that's the difference between TCP and UDP. You might be wondering why anyone would use UDP because like I mean TCP looks like the best solution you could have, right? But you realize that because of the because TCP has to verify if the other end of the connection is alive, right? It takes time before sending the data, right? So in certain situations where you want to prioritize speed over like maybe order, then you would use UDP, because with UDP it just sends the data, right? So if you pick a streaming service, or if you pick maybe this streaming service, you pick something like YouTube, you want a case where the data is always being sent, right? It's not now that you'd have to wait for it to establish a connection before the data is being sent. You want it to continuously be sent, right? Another thing is maybe a phone call, right? When you're making a phone call with someone, right, and then maybe the connection drops, you don't want a case where it has to re-establish the connection before you can get the person's voice, or the person's what the person was talking about. You want the communication to happen in real time, right? So that's where UDP is normally used. It's normally used in real-time communication. It can also be used in various aspects and various ways, right? So that's basically the difference between TCP and UDP. Right? So when we are doing port scanning, right, just specify whether you are doing a TCP or UDP scan. The most common scans that you see people doing are TCP scans, but you should also forget about UDP scans, because they are very juicy things, or they are very interesting things that you could find on UDP scans. If you look at something like, or if you look at, okay, I've forgotten, but you let's see, right? I'll come back to it later. So basically, how does the port scanner work? We spoke about what port scanners are. We've spoken about the difference of port scans. Right now, we want to how these port scanners actually work, right? Um, how how are they able to detect and know that some particular port is open or closed, right? If an Nmap before, how is Nmap able to detect and know that particular port on this machine is closed or it's open, right? So to be able to do that, a port sends a network request to a specific TCP or UDP port on a computer. So it sends a request. It tries to establish a connection to that particular computer on that particular port. And the computer that is trying to establish the connection, right, would respond with some particular state, which will allow the application or the port scanner to know whether that particular port is open, closed, or filtered, right? So you can see we have different port statuses over here. Now, if computer response is open and accepted, then it means that the computer is alive, right? Or that particular port is open. Now, if response with closed, it means that that particular port has been closed. And then if it a response with said dropped or blocked, it means that the computer has maybe a firewall, or is just probably blocking all connections to that particular port number, right? So now we know that there are three different situations that you should be looking out for when you are doing port scanning. Okay, but with the port scanning we are going to do today, we are just going to be focusing on the just open, closed, right? For filtered, you'd have to do little extra, but I'll just leave that for you guys to do on your own, right? Just to make or to boost your interest in it, right? So during your time, right, you can maybe I can even push the code to GitHub. You can pick up the code and see if you can make any changes to it, right? Try to implement different things, right? So, because of time constraints, right? We are not going to be writing a fully fledged port scanner, right? We just want to write a very simple port scanner that has the basic understanding of how port scanners work. Okay, so before we even start writing our port scanner, right? If you look at the way TCP works, right? It basically uses a three-way handshake before data is sent between the devices, right? This three-way handshake is meant to be able to establish a connection, right? So before the connection is established, the client needs to know that the server is alive and is waiting for data to be sent to it, or the server is basically alive, right? The server also wants to know if the client is also alive and waiting for data. So it performs what is called a three-way handshake. So with a TCP three-way handshake, the first thing that is sent on the wire, right, is the send packet. So first of all, the send packet is sent to the server, right, and then the server responds with the send act. So if the server is live, right, then it can give a response that is a send act, right, and then when the client receives the send act, it also sends an act to let the server know that the connection has been established and now data can be exchanged, right. I'm going to speak about something later on. I don't know if you guys remember Nmap stealth scams, right? Where Nmap say has this stealth scans that cannot easily be discovered. Now, what happens with these stealth scans is that instead of Nmap to make this full TP three-way handshake, right? It just sends this chain packet and then mainly receives the synapse. It concludes that that particular port is open, right? And through that, you are able to achieve stealthiness because the connection is never completed or the three-way handshake is never completed. So that's why it's called a stealth scam, right? We look at what the this particular diagram looks like when the um, maybe when you send a connection or when you try to initiate a connection with a port that is closed or filtered, right? Okay, so what should we expect when a port is closed or it's filtered, right? Normally, when a port is closed, right, and you send packet to it, it responds with an RST. RST basically means reset. Send means synchronize, and act means acknowledge. I forgot to mention that previously, but that's just by the way. So when you try to connect to a particular server on some particular port, right, and it responds with an RST or an RST packet, then it means that that particular port has been closed by that server. Right? The second thing is that if you try to send a send packet or if you send a send packet to the server, right, and then you realize that you're not getting any response from the server, then it could be either that the firewall is blocking or yeah, the firewall is blocking or is dropping that particular send packet. So in that case, you can say, or that in that case, the port scanning tools will tell you that that particular port is filtered, right? So these are the basic things that you need to know before like writing a port scanner. Okay, so let's see what's next. So let's get coding, right? Let's start writing a port scanner. But before I start writing a port scanner, are there any questions for me?
Um, what programming language do you recommend that we use for this?
Okay, so you can use any programming language of your choice, but um, I chose to use Python because it's much easier to use Python to write a port scanner, and yeah, it's much more easier to write Python. You don't, I, I let me see. Yeah, basically Python because Python is easier. But you can use any other language. You can use Go. You can use C. You can use C++, and the rest. But normally hackers like to use Python because of its simplicity. Like you can easily whip up a script in Python, right? So let's say you are doing some particular, maybe you are performing some particular hack. Maybe the particular system that you are on, right? You don't have access to tools like Nmap, right? You can just write a basic port scanner. Let's say their particular system doesn't have Nmap, right, but it has Python. You can just whip up a script that you can use to do your port scanning. You can also use Bash to do your port scanning, right? You can use Bash to automate maybe tools like Netcat to discover open ports on your target. Any other questions? And I hope I've answered the question. Yeah, any other questions?
Oh,
All
so
right, so
there is another question on the chat.
okay.
So Bash wants to know, can we use Golang or JavaScript too? And what concepts do we need to know?
Okay. So you can use Golang, you can use JavaScript to do port scanning. I wouldn't really advise JavaScript because JavaScript is normally created for the web, but you can still use it though. You can still use it though, and you can also use Go. I think Go is also one of the popular languages that is normally used for port scanning and creating, establishing connections between machines and all that. So you can use Golang. Yeah, you can use Golang. Thinking of even doing this in Golang, but I felt like Python will be much more understandable because Python is like plain English, right? Python is like basic plain English, and it's something that everyone can understand, where everyone can read and understand.
Yeah, awesome, awesome. So basically, in conclusion, it's really not about the programming language, but some other factors, just like, is it beginner friendly? Does it have libraries and dependencies that have certain modules we might use in our code? So don't be fixated about the language, but if the language has the capability, the modules, libraries that you need to create the tool that you need. Basically, just the use case. Then you can go ahead and use whatever language that you are comfortable with. But in this session, we are using Python because it is beginner friendly and very easy to understand. Thank you.
Okay, so when it's the concepts that you need to be able to write a port scanner, you basically need to know how to do socket programming, right? So port scanners just boil down to socket programming. So we'll get to that. If there are there any other questions to ask you?
This is from Bash also. He wanted to know what of cybersecurity concept to know, and he's a total beginner. I think we addressed this question in our previous session when we were doing we had an open forum for discussion of entry into cybersecurity, what you have to know. But I'm going to make it brief for you, but you can go back and watch that video as soon as it's available on YouTube. So the easiest path is just learn the fundamentals, programming, networking, databases, and with that, you should be okay. And then learn operating systems, Linux, Unix, Windows. Just choose one, understand programming, learn an operating system, and then your networking. That is under fundamental. Get to know that, and then we can build upon that. So thank you, Bash, for asking that question. There are no further questions in the chat, so I guess we can go ahead and start coding.
Okay, that's wonderful. So I'm just going to pause for a while and then share my screen. Give me a second. Okay.
So as we wait for Maxam to share his screen and then we start our programming environment, we are reminding you this is Byte Time sessions, and we have Wednesday sessions, not just today, but every Wednesday. So we are glad that you guys are joining us today. Make sure you visit our YouTube channel, search for Byte Time sessions, and then you see our channel. There are a lot of educational content and videos from our previous sessions. Make sure you subscribe. And then when the content is beneficial to you, make sure you share with your friends too. So I guess Maxam is ready. We can begin now.
Okay. Okay. So before you write any program, like you need to have an algorithm, or you need to have a series of steps that you are going to achieve whatever you want to achieve, uh, whatever you want to achieve, like when programming, right? So I think it's advisable, unless maybe you are really advanced or you have done that particular thing several times, like it's really good to like write down the kind of steps that you have to follow to be able to achieve what you want to do. Right. So let's say the first thing you want to do, right, when writing a port scanner, just to think of a port scanner. When you're running a port scanner, what are the basic things that you take, or what are the big things that you need? First thing you need is the IP address of the IP address of um, the target that you want to scan, right? So first we want the IP address of the target, right? And then secondly, right, another thing that we need is the port that we want to scan, right? Scan, right? So with this port scan, I'm just going to start off with something really basic, and then we'll reiterate, right? And then would uh make it more advanced, right? So first of all, what we are going to do is I will write a port scanner that you just give it an IP address and a port, and then to return and tell you whether that particular port on that server is open or closed, right? As time goes on, we would automate it and then we'll make it like in such that you can give it a range of port numbers and it will return whether those port numbers are open, right? So we need the IP address, we need the port that we want to scan. What else do we need? All right, so let's say we have those two things, right? The next thing we want to do is we want to establish a connection, right, to that IP on that port number. So establish a connection. Over here, I'm just going to say a TCP connection because TCP port scanner that we are building, right? So establish TCP connection So the IP on the specified port. Okay. So we establish a connection, a TCP connection IP on that specified port, right? Next thing we want to do is we want to check the response of establishing that connection. So when we establish the connection, we want to check what the server is responding with, right? Now, if we get a positive response, right? So let's say positive, uh, positive response, then we can see that the port is open, right? If we get a negative response, we- then we can see what port is closed. All right. So basically, this is what we want to achieve for now, right? So first of all, we need the IP of the target. We need the port to scan. We need to establish a TCP connection to the specified port. And establishing the connection, we check the response for that connection, right? So we want to check whether the port is open. If it's a positive response, right, you know that the port is open. If it's a negative response, you know the port is closed. Right? I hope everyone is comfortable with this algorithm. If you have any questions, you can ask. But if there are no questions, then I'm proceeding. Right. So first thing we want is the IP address of the target, right? The IP address of the target is user input, right? So we need to supply that input, or we need that particular input from the user, right? So over here, I'm going to use the command line input, right? See, normally when you run nmap, you do nmap, and then you provide some command line input, maybe 127.0.0.1, right? These are the command line arguments, right? So I want to get the IP address as a command line argument. Different ways you could get input. There's another function in Python to use to get input, but over here you use command line arguments because it just makes the tool easier to use, right? It makes the tool easier and simpler to use, right? So import a particular package that allows us to get command line arguments. It's called the sys package, right? And the way by which you can receive command line arguments is by specifying the arguments vector, right? So the arguments vector is just an array that contains all the command line arguments you could possibly have. So let me just call this command line argument, right? And for you guys to be able to understand this clearly, right? I'm just going to print out the command line argument, right? Print is a function that is used to display output, right? It used to display output to the console, right? So I'm going to run this currently.
Sorry, sir. System dot
Yeah,
argument is it like an uh, Python thing?
yeah,
Is it
it's
like
a
a
Python
Python module?
module.
Okay,
Exactly,
all right.
it's a Python
All right.
module.
Thank you.
All right. So it's a Python module that allows us to access the arguments that we provide to the program. Right. So I'm going to call this. The name of my script is called and I'm just going to provide some random arguments. So let's see by time session, and just going to say hello, and then let's see what gets printed out. So you can see it clearly over here. So this is what the sys.argv returns, right? So you can see the name of the program that you are running, portscanner.py. You can see the first argument, or you can see one of the arguments called by time session. You can see hello, right? So these are basically uh, the arguments that we pass to it, right? We're able to get it into our program, and then we are now printing that out to the terminal, right? So over here, right, this is how we want to run the program. We want to do port scanner.py. We provide an IP address, right? And then we provide a port number that we want to check if it's open, right? So we want to take two things. We want to take the IP address and then we want to take the port number, right? So we are going to create two variables that are going to hold those values, right? So I'm going to call this IP and I'm going to say dot argument the argument vector, and I want the first, that is it. Let me see the first argument vector, that is this, right? Normally in programming, we start counting from 0. So this is like the 0th position, and this is the first, and then this is the second, right? So I want the first argument. So I'm going to put 1 over here. So I want to index the first argument. And then for the port number, who can guess, I mean, what I'm going to put in, the number I'm going to put in for the port number? Which argument or which index am I going to use? Hello?
Yeah, 2.
2, exactly. That's wonderful. All right. So IP address is what? IP address is argument vector 1. Port number is argument vector 2, right? Now that we have, we've been able to accomplish these two, right? So let's see content. And then this is also completed. Right. So next thing is that we want to establish a TCP connection on that specified port, right? To the IP on that specified port, right? And then we would check the responses and all that. Now, to be able to create a TCP connection, right, we need a particular module that is in turn called socket, right? In every programming language, if you want to establish a TCP connection, you need what is called a socket. Now, in Python, there's a particular library, or there's a particular library that allows us to be able to use sockets or to write or do programming, right? So the library is called the socket library, right? And it comes inbuilt in Python, so you can just spin it up. You don't need to install any library. You can just type them in, right? So it's called the socket library. And before we can use the socket library, we need to create a socket object, right? You don't need to worry about this much, especially if you are not someone that writes Python. Maybe you can later on go and learn about Python classes. You understand why we are doing all this, right? So first thing we need to do is to create a socket object, right? And then we need to specify some particular parameters that will determine which kind of connection we are trying to make, right? Whether it's a TCP connection, the UDP connection, whatever. So first thing that we have to provide to this particular function is the family or the address family. The address family is basically to tell the socket module whether we are dealing with IP version 4, IP version 6, or which particular family of addresses we are dealing with, right? So over here, I'm going to provide it socket dot af inet, and by uh, sorry inet. Okay, let me just exit this and clear the term now. Yeah. Okay. So first argument is socket dot af inet. If you are not a
Sorry,
Python
what's the
programmer,
AFINet? What does it?
okay. So af inet is just a constant, right? When you print the value of socket dot af inet, it's just a constant to tell the socket module the family of IP addresses you should use, like whether IP version 4 or IP version 6. I don't know whether that's clear. Is that clear to you? If that's not clear, I could explain further. So when I hover over this function, right, you can see what this function expects as argument. Right, we have what the address family, we have the type, and we have the photo, and then the file number. But for now, focus are just going to be on these two, right? We want to tell the socket module which kind of the address family, the family of addresses that we want to use, like whether IP version 6 or IP version 4. Now, when you specify AF inet, right, then you are in the socket module that you want to use IP version 4, right? When you specify AF inet, it means you want to use IP version 4, right? So second argument is the type, right? So with the type, you remember that I talked about UDP, and then I talked about UDP, and then I talked about TCP, right? Over here, we want to build a TCP port scanner. So would use socket dot stock socket dot stock stream. Now when you specify socket dot stock stream, right, it means you are going to use TCP, right? If you select socket dot or stock dot dgram or socket dot stock underscore dgram, right, then it means you are using UDP. But if you select socket dot stock underscore stock stream, right, then it means that you are using what TCP. So over here we have this code over here. So basically we are creating a socket object, right? You don't have to worry about this too much if you are not a Python programmer. You can always learn about this later on. But this is one of the necessary things we need to do to be able to establish a connection, right? We need to tell the socket module the class of IP addresses we are using, like the family of IP addresses we are using, right? Over here, we want to use IP version 4. So we are specifying socket.af inet. That is only in the socket module, the family of IP addresses that we are using, right? And then we want to also tell the socket module whether we are going to use TCP or UDP, right? Now, when we specify socket.stock underscore stream, right, then it means that we are going to be using TCP, right? It means that we are going to be using TCP. So now that we've created this object, right, we can use this object to create a new connection, right? So over here, we are going to create what TCP, and let's put this to write this in cap TCP connection. All right, so I'm just going to say socket stock dot connect, right? And I'm going to use connect x. So what this method does is that what this connect x method does is that it's going to return a boolean, right? Or let's see, it's going to return a number, and it's going to return either 0 or 1, right? It's going to return either 0 or 1. Now 0 means that if it returns 0, right, it means that the connection wasn't established. If it returns 1, sorry, if it returns 0, it means the connection was established. If it returns 1, it means that the connection wasn't established, right? So we are going to write conditions to handle all that, right? Now, if the connection is established, then we know that the port is open. If the connection wasn't established, then we know that the port is closed. So if this particular piece of code, right, when we use to create a connection, right, if it returns 0, right, then it means that the connection was established. If it returns 1 or anything apart from 0, it means that the connection wasn't established and that particular port is not open, right? So with this connect X, we want to supply it our IP and then port number, right? And I'm just going to assign this to a variable called connected. I'm just going to assign it to a variable called connected, right? So I'm going to write a condition over here. I'm going to say if connected is equal to 0, right? So if it returns 0, then it will print out port port, then the port number. So port and the port number is open on then the IP, right? Don't worry about this. I'm going to be explaining it shortly. So basically, this is a print statement, and we are using an F string. The F helps us be able to put variables into the output that we want to display in the terminal, right? So over here, I'm just saying that it should display this output, the port number, and then the IPs that we are trying to connect to. It's just going to display that to the terminal, right? Now, if that particular condition is false, then this else condition will get executed. Now, if the connected is 0, right, the other or whatever condition that comes later on means that connected is not equal to 0, right? And it means that the port is closed. So we can just assume, or we can just say that apart from it being equal to 0, we can conclude that if it's not equal to 0, then it's closed, right? So we can say print, and then we use the same F string, and then we say what port, then we say port. So the variable port, we bring it over here so that it can be printed out to the terminal on. So is closed, closed on the target IP, right? So now we're see something pretty basic, right? We've been able to achieve all our goals that we set before writing this piece of code. You can see this piece of code is really simple. We are not doing anything complex, right? We are going to reiterate over this, right? And then it's going to get a bit more complex after this, right? But I'm sure you guys will figure it out. And I'm sure you guys will have a lot of questions for me by then. So I'm ready to answer all those questions, right? So now that we have we have this basic code written down, right? This is just a basic port scanner. It's not a complex one, right? We are going to run it with Python. I hope you guys can see my terminal. So Python port scanner. Then we provide the IP address and then the port that we want to check if it's open, right? So I'm going to use my local host, right? I'm going to use my local IP address. I think I have port 80 open. I'm not really sure about it, but let's just check, right? Okay. So you can see that we are getting an error over here. That's one thing about programming. You are going to run into errors, right? And I intentionally left it this way because I want you to see that when you're writing code, you're not always going to get it like 100%, right? You are definitely going to run into errors. And this is something that happens in the real world, right? You don't, most of the YouTube videos you watch, you see the person doing everything perfectly and then the person gets the output, right? But I want to show you that, like, while you're writing code, there are certain mistakes you could do. There are certain things you could overlook, right, while writing code. And you just have to look at the error and try to fix it, right? Over here, you can see we have a type error. It is string cannot be interpreted as integer, right? Now, the problem here is that the port number that we are taking in or this particular connect function, right, takes the port number as an integer, right? But it's over here when we take it from the command line, it's being passed as a string. I don't know if you guys have any question on that. When we take the argument or when we take the data from the command line, right, it's being passed as a string, and it's being passed as a string to this function. But this function only works with what integer values, right? So we need to convert this particular port number into an integer. So we are going to use that using the int function. Let me just close this up, and then currently what we are doing is that we are converting this port number into an integer, right? So now this particular function can accept our port number and then process it, right? So let's just run our script again and see. Okay, so you can see that I currently have port 80 open on my PC, right? The script is telling me that I have port 80 open, right? So just to confirm that, right, let me just close. Let me just HTTP, then 127.0.0.1 on port 80. And let's see whether it returns anything. You can see that it is returning something. I think it's the default Apache page or something like that. So you can see that that particular port is open, right? Let's check another port that is closed on the machine. Let's just see something like maybe 87. Okay, so it says it couldn't connect to the server. All right, so we've not. Oh, wait. Okay, it wasn't the script I was running. Okay, so let's say I'm trying to connect to 87. You can see that it tells me that port 87 is closed on 127.0.0.1, right? You can anyone get me the IP address of maybe Google or something? Let's just check if they have ports. I think they would have purpose to be open most of the time.
Well, we can try 8.8.8.8 or just use
Okay.
Google's. Yeah.
Okay, you know something, just ping Google and then let's copy this and then let's check if they have 445 open. 445. Wait, let's have done 443 instead. 443 is for HTTPS. That's I'm using 443. So you can see they have 443 open, right? 443 is normally used for HTTPS, right? So they have 443 open. So we can see that the port scanner is working to some extent right now, right? Now, what makes port scanners complicated is that certain network defenders putting certain measures in place, right, to make it difficult to tell if the port is open or closed, right. That is where the firewalls come in. So there are some cases in which the firewall could accept the connection, right, and drop it later on, or the firewall just could be messing around with you, right. And that is why Nmap is like a bit complex. Right? There's a lot that goes into Nmap, right? But this is the basic concept of how Nmap works. Right? It just tries to establish a connection. If depending on depending on the kind of response that it gets, right, it's able to tell if the port is open or it's closed, right? Currently, our code is really short and simple. Um, there are still certain things we can do in addition to this code to make it like a better port scanner, right? Maybe we want to scan certain port ranges, right, on a machine. We can do that too. One way to do over here is that currently we have this thing working. So I'm just going to put this in a function, right? And that function is is something I'm going to be calling later on in my code. Right. Now, when you are writing code, right, you want to write something that like when you're writing code and you realize that you are doing something repetitively, right? Let's say there's a particular piece of code that you keep writing inside your script or like inside your program or whatever. The most advisable thing to do is to put it in a function. So that anytime you need that piece of code, you can just call that code and then you can run it. And the reason why that is done is because memory is expensive, right? You don't want your program to be eating up too much memory on your disk, right? You can already tell, you can tell that when you are running Chrome, right, and it's eating up your RAM, it's really annoying, right? So as a programmer, you want to make sure that like your programs don't take up too much memory. Imagine you are writing all these things. Let's say you use this thing 200 times, and you are writing this particular code 200 times, right? This particular code will get loaded into the RAM, right, and it's going to take up space. So that's one reason why we use functions, right? So that we can, for code reusability, we can use that piece of code again and again, right? So I'm going to put this in the function, right? I'm going to put this in a function. I'm going to call this function scan. But as time goes on, we would improve this function. So this function is going to take in two arguments currently. Right now, it's going to take in two arguments. It's just going to take in IP, which is going to be a string, and it's going to take in port, which is going to be an integer, right? So once these things are passed to the function, right, the function will try to establish a connection, a socket connection. So I'm just going to copy all this code and I'm going to put it inside the function, right? Python indentation, you need to make sure the code is properly indented. Okay, I've done that. And then we have this function, right? So now when we run the script, right? Okay, so currently what I have to do is, now that I've created the function, I have to call the function. So scan port, and then we pass in our two arguments. That is the IP and then the port. And then it will do the scan and then print these two statements for us, right? So I'm going to run the script again. And then you see that when we implement functions, it still works the same. So 127.0.0.1 on port 8. And you can see the script is still running successfully. So can anyone think what I'm supposed to do if I want to scan some particular port range? Right. So okay, if there are no suggestions, right, I'm just going to I'm just going to do it. Okay, so basically if you want to scan some particular port range, right, you need to take input from the user as usual, right? So you want to scan maybe from maybe let's say port, maybe you want to scan from port 1 to port 20. The user should be able to enter this input. Now after the user enters this input, right, we take it into our script and then we start counting or we start trying the connection from 1 to 20, right? And checking if those ports are open 1 to 20. And then we keep returning the statuses every single time, right? So one way we can do this is that we can use a for loop. But before we even continue, right, um, let's just take let's just change the way we take our input. So before we do that, right, let's change the way we take our input. If someone keeps requesting access to my PC. I can see we have a lot of hackers here. Someone wants to hack me, so and then we want to end. Okay, and then we want to end at the end port, right? Let me just go over again. So it's just a second. All right. So okay. So we want to like scan port ranges, right? We don't want to be able to scan just one port and then that is it. We want to be able to scan port ranges. So for example, we want to start from port 1 to port 20, right? Over here, what we are doing is that instead of just taking one port number now, we are taking two port numbers, right? Where one of them is the starting port and the other one is the end port, right? So what's going to happen is that we'll write a loop, right, to continuously call this function, right? And then we'll be providing a different port numbers to do the scan. And it's going to tell us either particular port is open or not, right? So over here, we are writing a loop, right? So we are saying for ports in this range of numbers, right? So it's going to pick a particular number within this range. It's going to iterate. So it's going to start from the first number that we give it. So we're going to start from the number 1 to the number 20, right? If those are the inputs we are giving it. So we're going to start with 1, 2, 3, 4, 5, 6, 7, 8, up to 20, you understand? And it's going to call the function that number of times to check if those ports are open or closed, right? So now that we have the start and then the end port, we can proceed, right? So just to confirm that we actually getting a good port range, right? I'm going to print out I'm going to print out the start and end port, right? So I'm going to say this is so I'm going to say let's just say this is our current port, right? And then we'll say port, right? Okay. So now let's run this again. 127.0.0.1. We'll bring the logic for scanning, or we'll call the function for scanning later on. Right now, we just want to see if it's actually able to get the input we are providing it to. I'm going to say I'm scanning 1 to 20, right? So these are my arguments. So first thing is my IP address, and then second is my starting port, and then the last one is what my end port. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It ends at 19, right? Now, one thing this range function does is that it it doesn't end at this particular last number that we give it, right? It ends at the number before the last number. So what we can do is that we can just increment it by 1 so that we are able to reach the targets that we want, right? So let me run the script again and then we see that we have 20 over here, right? So what's next? What's next? We'll call a function, right? We'll call a function called scan port. And scan port takes in was the IP, which has already been provided to us, and then the port number. So we just say port. And then let me just clear the screen. And then now we can run the port scanner and you can see that we have port 1 is closed, port 2 is closed, port 3. So I think they are all closed. Now these ports are not commonly used ports. They are not ports that we normally use on our PC. Like we could try another range, like maybe let me see. Uh, let's see 70. Sorry. So let's say 70 to maybe 100, right? And I think within that particular range, we should get some open ports. We have port 80 open over here. Now I realize the output of this script is not really nice, right? So as a programmer, it's your duty to actually make your program better, right? And make the output much more nicer and easier to work with, right? So we'll do that very soon. Okay. So what we want to do right now is that instead of just printing out the term, we would store the open and closed ports in a list, and then we only display the open port, right? Because we don't want so much output, right? So what we can even do is, so before we even do the list, or before we even store it in a list, right? let's just print nothing, or like will not do anything if it hits the else condition. Will not, because we don't want closed ports, right? We only want to open ports. And then when we run the script again, you can see that we have only port 80 open. So it is scanning this range from 70 to 100, and between 70 and 100 it's only port 80 that's open, right? You can further fine tune this tool, like you can make it much more better, like you can add other things, like you can add banners and stuff. Let's just do that, right? Now, when you're writing a script, right, it's not always you that is going to run that particular script, right? You need to make it user friendly so that if someone picks up your script, they can easily run it. So one thing that we also like to do is that you want to give the user, like how should I even put it, a manual on how to use the tool, right? So we can write a function called let's just call it welcome. Oh, no, let me just call it help, right? So I'm going to call the function help. What is basically going to do is going to present us it's going to display a help screen on the console, right? It's going to display a help screen on the console when the user wants information on how to run the tool, right? So with the help screen, I'm just going to print out. So first of all, I'll tell the user that this is the usage and this is how to use the tool, right? So I'm going to say this is the usage of the tool. So first of all, we need the axis, we need argument vector one, right? Argument vector one is the name of the script that we are running, right? We just want to tell the user that okay, this is the script that we are running, and then this is the arguments that are supposed to follow, right? So what is the first argument we give it? I think we first give it the IP address. So we just the IP address, and then we say start port, and then we say end port, right? So you can see this is the usage of the tool. What we are going to do is that anytime the user provides this particular, let's say the user does maybe minus h, it should give us some particular output that will show the user how to use the tool, right? So what we are going to do is we are going to write another main function. Okay, so we are going to write another main function. Now the main function is what's going to be executed first when the script is being run for the first time, right? So let's just create a new function called main. Let me just do that down here. That main, and basically that main function will run anytime before this code, right? So what we want to do in this main function is that we first want to check the arguments, right? So if this dot argument vector um, one, right? So this argument vector one is equal to minus h meaning help. User wants like a help screen. If this dot argument is equal to um, if the argument or the first argument vector is what minus h, what we want to call the help screen, right? So I'm just going to call the help function here, right? So what will happen is we'll just print out the help screen, right? I'm going to add another condition. I'm going to say that if the sys.argument is minus h, or maybe the number of arguments that we require, the person hasn't provided it. You see, the person maybe the person didn't provide start and end port. The person only provided one port, right? Then we would also print out the usage of the tool to the user for the user to know how to run the tool, right? So we are going to say if what sys.argument argc. Now argc stands for argument count. That one basically returns the number of arguments that you have in that array, right? Remember when I printed sys.argv, so like it will return some particular array with some items in it, right? Now when you count those number of items, that is sys.argc. Sys.argc defines the number of arguments that the script needs, or the program needs to run, right? So I'm over here, I'm telling the script that if what I'm going to tell the script is that if, like, let's say the user doesn't provide all the required arguments, right, then print out the help for the user to know how to run the tool properly, right? So if this.axc is what less than the number of arguments that we need, right? So the number of arguments that we need are three, right? Because we have, sorry, this is one, two, three, four. Okay, so if this.axc is less than four, right, then print out the help so that the user knows how to run the tool. Okay. And then these particular things I'm going to take them later on, right? So I'm going to move these into the main function, right? I'm going to move this into the main function. So now when we run the code, this is being taken. And then I'm going to move the port scan to also the main function. Okay. Okay, so I need to indent it because it's under the loop. Alright, so now we have script is simplified it over here. It's looking much better. Normally when you're writing code, you want to make it very readable, right? That's why I'm using functions and all that. Also, we want to have code reusability, right? So we have a scan port function over here. We have a main function over here. Now, functions don't get executed until you call them, right? So over here, I've only defined the functions, but I've only defined the main function, but I've not called it anywhere. If I want to use or make sure the code in the main function runs, I need to call it inside the script, right? So over here, I've called the main function, and anytime I run the script, the main function will run. So what happens when the main function runs is that it's going to check the first argument. If it's a minus h, if it is a minus h, then it's going to what execute the help function. So it's going to show the user how to use the application, right? If it also realizes that the arguments are less than 4, right, it's also going to print out the help for the user to know how to run the tool, right? Also, so if it passes all these conditions, right, if it passes all these conditions, it sees that, okay, this is not equal to h, and also the arguments are equal to 4, right, then it's going to skip this particular block of code and then move on to the next. So when it moves on to the next, it is going to first take the IP, it will take the start port, the end port, and then it runs the port scan, right? So let's do that quickly and see what happens. So I'm going to do with minus h, and let's see what happens. So it says was list index out of range. Okay, okay. That you know what why that is happening. Even though um even though I'm running this particular code over, right? It continues to go and run the ones down there. Now I need to add a particular statement that will make the script quit or exit immediately, like it realizes that the user hasn't provided the right input, right? So you can do that with, I think, you can do sys.exit, right? I think you can do sys.exit, and it's going to exit the program. I think you can, let me just execute with, let me just exit with exit code 1, right? Normally when a program exits gracefully, it exits with exit code 0. So let's run the thing again, and then you can see over here, it prints out the usage, right? And then the program exits, right? So now the user knows that, okay, we have port scanner, and we need to provide an IP address, a start, and then an end port. Just add this quickly, a start and then an end port, right? So this is just one iteration of the port scanner. We can keep adding other things to it, making it more advanced and making it more faster, even put it, making it more efficient, right? Now, if you look at port scanners like Nmap, they don't just check the connection. Some of them will actually check the connection, try to send data to that particular connection and see if it retains, that particular port retains any data, right? I'm just going to do a small demonstration over here. Let's say we are connecting to a particular web server with Netcat, right? 127.0.0.1. Remember that I had port 80 open. Now, when you connect to it, you can see that there's nothing happening, right? What other port scanners will do is that they try to send input to that particular port based on the port number. So they know that maybe port 80 is normally for HTTP, right? So if it's HTTP, then it's going to try to send HTTP data on that port to see, or HTTP request on that port to see if the server is going to respond with anything, right? And when it responds with something, it's going to grab that particular banner and it's going to present it. So that's how Nmap is able to do service detection, right? It's able to know that, oh, WordPress is running on this particular site, right? Because it sends the request and then it gets a response and then it's able to determine that. So I'm just going to do get flash. I think I can just add HTTP 1.1 and let's see what happens. You see, so we got a response. Right, we have bad request because I didn't have the request properly, right? But you can see the server is Apache, and then you can see we have like interesting data over here, right? So this is what Nmap will pick up and then we'll add it to the result of the scan, right? So basically, this is what Nmap is doing in the background, right? So, but with our port scanner, we are not going to be doing all that. We just want to check if some particular port is open or closed, right? So, I don't know if there are any questions for me up to this point. Do I have any questions up to this point? Hello. If there's anything you don't understand, maybe something I did that you don't quite get why I did, you can just voice it out and then I can go over again.
Okay, so for the main function, yeah, at that point my
Yeah.
network was breaking, so I don't really get it. Can you please go over for me?
Okay. Okay. So I was saying that like when you are writing code, right, you want to write the code in such a way that it can be easily be read, right? And functions are a way of writing code in such a way that you can easily read it. Another thing too is that when you're writing code, you want to make sure that any code that is going to be reused, right? You put it in a function or you make it a function, right? So anytime you're writing code, you realize that you are doing some particular thing more than two times, right? Then it means that you have to put that particular thing in a function, right? But sometimes you can also create a function just for proper readability, right? Because I wanted the thing to be properly arranged. So what is going to happen is that when we create a function, right, the code in the function doesn't run until we have called the function, right? So this is the function definition, right? So we have def main, right? This is the function definition, and then this is where we actually call the function to run the code in it, right? So the code starts running, right? Python will go through the script, right? The way Python executes code is that it executes code line by line, right? So it's going to look through this code and see what it can start executing over here. So it maybe gets to start from line one. It says import sys. So it goes to look for the sys package on the system. Like if you are running a Linux system or a Windows system, it looks for the sys package. The sys package is basically Python code that we have somewhere else, right? That helps us to write our script. That makes it easier for us to write our script, right? So a library code in Python is basically Python code that lives somewhere on our machine. That helps us to be able to write our code easily, right? Because if this package didn't exist, we would have to actually write the implementation for this package and then the socket package too, right? I hope that's clear. So when that happens, what's going to happen is it's going to move on to the next line, line three. There's nothing on line three. You can move on. Line four, it realizes that this is a function. So it doesn't execute anything that is under this function. It probably maybe just loads it into memory and then keeps the memory address of this function. It goes to this function and also sees that it goes to line seven, also sees the function. It stores the address of the function in memory and then moves to the main function. And the main function, it sees that okay, this is a function, so it also stores it in memory. So the function is not run until it has been called, right? So over here, you can see that we have called the main function over here, right? So now that we have called the main function, Python knows that okay, now the main function has been called. We can start running the code inside the main function. So it goes back to look for the address of the main function, right? And it starts executing the code inside the main function. Over here, you can see that the first line of code in the main function is first checking if the first argument of the script is minus h meaning help, right? So if the user maybe wants help or knowledge about like how to run your script, right? Particular condition checks that, right? So now when a person enters -82, right, it's going to print out the help screen and then it's going to exit the script, right? So the user is able to have a fair idea of how the script is supposed to be run, how they're supposed to supply arguments to the script, right? Because when the help function is called, we print out this message that gives the user an idea of how to run that particular script, right? Also, if the user doesn't provide all the arguments necessary for the script to run, right, we would also call the help screen and then we'll exit so that the user knows that, okay, I need to enter this number of arguments before I can get the script to run and actually choose what I want it to do, right? And when that happens, right, we just exit and then the user has a chance to run the script again. Okay, now if it passes all these conditions, right, if all these conditions are met, right, it moves on to the next line, that's line 25. it it takes the IP from what the terminal, right? It also takes the start port from the terminal, takes the end port from the console, and then it does starts doing the port. So with the it starts from the start port and then ends at the end port, right? I already spoke about this, the Python range function, and that it always stops at a number before this end port number, right? So we need to append it, or we need to add one we need to add like a number to it. So we need to add one to it so that we can get that particular specified port range, right? So now when that happens, we can call the scan port function and then it will start doing the scan, right? So anytime you want to do a new scan, right, it comes here, calls the scan port function, provides it's the current port or the current iteration that we are on, right? And then it calls that, it supplies to the port. It does all these checks and sees if the port is open, right? I hope it's clear. I hope I've explained it clearly. Yeah. So Lama, I hope you are fine. If
Yeah,
you
yeah,
want any more clarifications, you can let me know.
Hello.
I see there are some. I don't know if there are questions in the chat. What can you check for me?
Um, Not really. There isn't any issue, but I think we'll address that it is on a sideline. I think Bash is trying to do the same thing where he's trying to write the code alongside with us and he's getting some error. I'll just address that in the chat. So we're fine.
Hello, Master.
Okay, okay, okay.
Hello.
So yeah, hello.
Yeah, please can you just explain the sys.axc a little bit?
Okay, okay. So I explained that sys.axc is the number of arguments that were provided to the script, right? The number of command line arguments. So you realize that if you are running a two-line map, right, you provide an IP address, a 127 dot zero dot zero dot zero dot one. I hope you can see my terminal. It's down here. Let me just take this like that. Uh, okay, that's it. Okay, so you can see that we have 127.0.0. Maybe you've also provided a port now, right? I think you use minus P or so, right? What's happening is that you are providing certain arguments. Over here, let me just put 90. You are providing certain arguments to the nmap 2, right? That is first the IP address and then the port number. Now, the argument count will count the number of arguments that are provided to the script. So over here, we have one, we have two, and then we have the script itself or the program itself. So we have three arguments, right? I don't know if you get it. So let me just do a small demo for you to see so that you understand it better. I'm just going to comment out this main function. Um, I'm going to print, first of all, I'm going to print uh, so I'm going to print content or arguments. I'm going to call them arguments, right? And arguments are going to basically be sys.argv. Okay. Sys.arguments vector, sorry. And then I'm going to say arguments count. Sys.argc, right? Now, when I run this code, right, it should print out the arguments that are provided to the script. So let's just try that. Include, go back. Okay. Let's see, 127.0.0.1, 1990, and then let's, oh, I'll see. Oh, Python doesn't have that module. Let me see. Argument. Oh, okay. So Python doesn't have args, right? It exists in other languages like C, right? That's why I thought argc. But if you can't get argc right, you can do sys.argv, but you just calculate the length of that particular array, right? So you can just use the length of that array. Let me just change this over here. You can do length of sys.argv, right? So what it's basically doing here is that it's just checking the length of this array. So let me run this again and you'll see the output. Okay. So you can see that these are the arguments that we have. It's a list that contains the arguments that we have. And then you can see the number of arguments that we have. So argument count is the number of arguments that we have, right? And the arguments are actually the actual arguments that are provided to the script. I don't know if it is clear. Is it clear? Are you fine?
Yeah, I'm okay.
Okay. So argument is the number of the arguments are basically the arguments you provide to the script or the text data you provide to the script. And argument count is the number of arguments that are provided to it, right? So over here you can see the script itself. That's port scanner.py, right? And you can see 7.0.0.1, and you can see 99. In all, they make up three arguments. So you can see argument count is what it is. So that's a basic port scanner. Now this can be improved in so many ways, right? You can use threading, right? So that you can use threading to make multiple connections, so that it's not like you have to constantly be running a loop, right? You can use multi-threading to establish separate connections and to check if the ports are open to make your port scan faster, right? You can also look at doing banner grabbing, right? So when you connect to a particular port, you can send some particular data based on the kind of port it is, right? You can send some particular data to the port um, for it to and see what response is going to give you, right? So if you use some particular type of response, you can know what service is running on that port, right? So that's basically what map and those other port scanners do. Right? So they connect to that particular port, they send data to it. So when the port, they see the port is open, right? They send data to that port and see the response from that port. And when they get a response from that port, right? Most of the responses contain the banner of the service being run on that port, right? Nmap just captures certain information from that particular banner and then presents it to you on your screen, right? Um, I think time is fast, and I think we have about 13 minutes left. Are there anything are there any things that you want me to add to this script, or anything that you need to clarify, or anything extra you want me to do? I mean, this tool can be improved, right? This is something really big, just to get you started, or for you to understand properly how planets work, right? If you want to make this tool really fancy, right, you can just print maybe some ASCII art or something, right? So you can just print some ASCII art, right? You can have some ASCII art over here. Mm, you can say maybe welcome to by time 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 session for Sana, right? You can print something like this. You can choose to also make it fuller. Maybe you can do something like this. Let me just try to do something a bit fancy. I'm going to and then an extent. And one amazing thing about Python is that you can just multiply a character, like, and it's going to appear that number of times. Like I'm going to do that 10 times. I'm going to print welcome to byte time session for Ghana. Right. I'm going to print, sorry, I'm going to print this also 10 times. Right. Now let's run it and let's see what it looks like. Uh, you get it. You see, so it's giving us some small art over here. Let me just make this 20, 20. We can make this nicer. Like there are these websites that allow you to be able to do ASCII art. And when you like you can basically some text and it was going to get some very fancy and nice ASCII art for you and you can just put it into your script to make it just make it look nice. I mean just for street cred, like you can just write a simple script and you put it on Twitter and I mean just for some street cred, right? That's just it. But if you want to come let me just reshare my screen. Just give me a second. Let me share my entire screen. Okay. So so let's see. ASCII, ASCII. It's called ASCII art, right? ASCII art generator. You can just generate some ASCII art. Let's call it by time time session. You can choose different types of fonts and stuff. They are very cool ones. And let's look for something that's really fancy. Okay, I think this
Was
is
it on your Kali you were coding?
hello.
Was it on
Is
your
it?
Kali you were coding?
No, this is actually a website I'm
Was it on your
doing this
Kali?
on. There I wrote the
I mean,
code.
I say, was it on your virtual machine?
No. This is I use Ubuntu as my host machine. Yeah, you can do this on any Linux
Okay,
machine.
okay.
Yeah. So I'm just going to copy this, right? And then I'll put it in my script and just make it look fancy, right? So I can just use a print statement to print, right? I mean, if you feel like you are well versed in some other programming language, you can use that. I would really like to see. You can always contribute. You can always show it off in the group. I'd really like to see you writing in another language. You can probably use Go. Let me see what other language you can use Rust. I mean, just a basic port scanner, right? So let's run this again and see. Okay, so you can see. So we have this in our script looking fancy, our tool looking fancy over here. So when you see all those fancy tools, like this basically how they are built, right? They are built from scratch, little by little, and then they get to this stage, right? Now, maybe this could be a bit annoying for some people, so you can add another condition, whether to print this or not. So you realize that with certain tools, like there's this quiet mode you can do. I think with Metasploit like this, you can allow quiet mode, and it's not going to print out this banner, right? But if you just want a full and fancy banner, you can do something like this. I think there's also another trick where you can start printing it line by line, right? And you put a delay in there. we'll print this out like line by line. These things are not really important. It's just to make the tool look really fancy, but they are not really important. The other things you can do when it comes to the port scanning, right? Sometimes it's going to throw some errors, right? You can handle the errors with a try and a cut. Right? So you can do try and then sorry, did I say try and cut? No, in Python it's not try and cut, right? It's try and accept. So you can do try and accept, and then you can say exception as e. So basically, you just want to assign that error value to the e variable, and anytime you can print out the error just to give the user some idea of what is happening. Right. If you want to write a fully functional script, right, it's going to take a very long time. We are not going to finish this evening, right? So this is something just to how shall I even put it, just to whet your appetite when it comes to offensive tooling, right? Once you understand the basics, you know how to write some particular programming language. You can just put in the hours, make your script really nice and fancy. I think I myself have written a pod scanner before. I think I wrote one when I was I wrote one back in school, right? So you can check that one out also in GitHub. Let me just go there. GitHub. Like what is pod scanner? Pod scanner. So over here you can see that I basically added extra stuff, right? But you can still add more to it. Like this is a little bit more advanced than what we looked at today, right? So you can also check this out. Over here I use thread, right? And I think I was taking the input differently, right? So it was actually inputs that I was taking when the program is run, right? So we can do the same thing over here, even though I don't really fancy that right now. But we can do the same thing over here and run the script, right? So I don't know if there are any other questions. Our time is almost up. It's 8:56 right now. If you want to see a part two of this where we add extra features to it, you can let us know. If there's anything you don't understand, you want clarification on, if there are any submissions, like maybe I did something some way you don't agree with it or you think you have a better way of doing it, you can just let me know. We are all here to learn from ourselves. Right. So the floor is if you have any questions to ask or any contributions to make. Right. And I also want to get feedback from you guys, whether you enjoy the session, whether you learned anything new, how you find the session. Do you want more of this? We plan to do more of this in the future. We plan to write more exciting things. Probably you might write a Telegram bot, right? A Telegram bot, and people use it for command and control. Use it as a command and control server. Like you write other very interesting things. Right? So let me just know. Let me just know what you guys think of this particular session. And yeah, so I guess that is it. So anything anyone wants to share or wants clarification on, you can the floor is yours. Yeah, hello. Let me just check
Awesome.
the chat.
So this has been a good session. I think Not may want to ask a question, so we briefly allow him to do that.
Okay.
Um, so Not me. You can just ask your question, please.
Yeah, hello.
Hello.
Please move a little bit down.
Yeah. I didn't quite hear you clearly.
Move it down. Move your code down a little bit.
Oh,
Yes.
okay.
Yeah, I'm still on the sys.rv. You said
Oh, okay.
if sys.rv1 is equal to help or in that
Kind
h,
of. Yeah.
or the length is less than 4, it should print out help, or it should call for the help function.
Yeah.
So as in our case, the length is going to be 3.
Okay. in our
and
case.
yeah, oh, yeah.
Okay. You see, the
You're
script
going,
gets added.
mm,
The name of the script added when like
yeah,
it gets
that's
added to
the
fix the
port
argument.
scanner dot by
Yeah,
your
exactly.
IP address and the port. That's three. Oh, yeah.
Yeah, but you remember that we wanted to do something we start scanning from some particular port and end at some particular.
Okay. I wasn't here. Sorry.
Yeah. Okay, no problem, no problem. So basically, we want to start scanning from some particular port and end at some particular port. That's why the arguments are four now. Right? But depending on use case, right? If you check my script over here, right, the way I implemented the range was different, right? So over here, what I did was um, I got port max and port min. So basically, the end port and then the start port. These are basically what I'm assigning over here. And what I did was that instead of giving the output separately, right, like the way we did over here, let me show you. Instead of doing maybe country port scanner the py 127.0.0.1, instead of doing maybe 1 to 280, right? In that particular, you actually put a hyphen over here to make it much more like sensible and much more readable, right? But I didn't want to do that over here because I didn't want it to be confusing. I just wanted this to be like really, really like basic, right? So if you guys want a part two of this, you can let us know. We can do this. We can improve this. We can make it better. Yeah. I hope you are satisfied. I hope I've answered your question.
Yes.
That's wonderful. Any other questions from the audience? Any other questions from the audience?
No, there is no hands up. There are no questions in the chat. I think we are satisfied. And if we have any questions, we send that in our Discord channel, ask on LinkedIn, ask on Twitter, maybe add it as a comment in when this video gets posted on our YouTube channel. So thank you, Maxim, for a great session. And again, you'll see that it is just an iteration of programming principles we're just applying here, adding learning new techniques, and then basically just the fundamentals, creating variables, assigning values, creating conditionals, and then defining functions, writing functions, and all that. So I hope for us beginners, we will take programming, operating systems, networking, very serious, because with the solid foundation in these aspects of computer science or IT, we can do and build up upon it to become great in the field that might interest us in later time in our career. So shout outs to everyone who joined us this session. This will be uploaded very soon on our YouTube channel. If you need to rewatch this again, have questions, please do so. And as he said, if you want part two of this model where we build on this to have extra functionalities, let us know, and then we'll do that for you guys. So thanks to everyone. Thanks to Maxam for holding us down, and for everyone who participated, Bash, Lens, not me, and everyone, Phoenix, and those who joined earlier on but couldn't stay. We say shout outs to you, and then let's meet same time next week. And have a good evening, everyone, and good night.
Good night.